Hello, everyone. It is my pleasure to welcome our next speaker to track 2. Software engineer, tech lead, and coffee lover. That is how he describes himself. With more than a decade of experiences, he specializes in micro frontend and microservice architectures, serverless computing, clean code, and reactive programming. Please welcome the founder of the same tech, Ildar Sharafeev. How are you today?
I'm good, good. How are you?
It is a pleasure to have you. Thank you so much for being part of the Micro Frontend Conference 2024. And with no further ado, the stage is yours.
Yep. Good night, everyone. I'm joining you live from Vancouver, Canada, where it's currently 2 a.m. So if I start to sound a bit loopy, it's not the lack of coffee, it's lack of sleep. Today, we'll be exploring domain-driven design, or shortly DDD, in the context of micro frontend architecture. And as an added bonus, we will delve into an architecture pattern with a name that might transport you back to the geometry classes at school. Before we start, shortly introduce myself. My name is Ildar, software engineer, tech lead, blog writer, double that. By the way, happy Father's Day, who was celebrating. So I was doing micro frontends in the last 7 years, and I'm super thrilled to be a part of this conference. You can subscribe to my blog, thesametech.com, and you can also follow me at LinkedIn. Sharafeev, that's my alias. And yeah, let's start. Let's start my presentation. So since this is a micro frontend conference, I will be brief, as you likely already understand the concept of the micro frontend and what is it. So micro frontend architecture involves breaking down a large and complex system into smaller, autonomous, and independently deployable parts. We can call them micro apps or micro frontends. So let's take a stroll down memory lane and recall some more traditional architectural patterns, such as MVC, model view controller, MVVM, model view model, and even MVP, model view presenter. If you are familiar with these, you've likely encountered them in various software development contexts. All these patterns are very similar in their nature, so I usually use acronym MVW to describe all of them. That stands for model, view, whatever. So in a very simplified form, this architecture can be represented as a layers, where business logic layer is kind of sandwiched between others two, like presentational and data access, or let's say like infrastructure layers. But what if we want our business logic or domain layer to take a central place? So it will not depend on lower levels. So there is a solution for that called hexagonal architecture, also known as ports and adapter architecture. Essentially, both the presentational layer and data access layer represent integration with external components. They have nothing to do with the system's business logic, so they can represent a single layer. Let's call this layer infrastructure layer. And finally, there is also a new layer called the interface layer that describes all the operations exposed by the system and orchestrates the system business logic for executing them. As you might see, business logic layer now doesn't depend on anything else. So it's in the center, in the middle of this architectural pattern. And in the next picture, you can see how it can be structured using like hexagons. That's why it was called hexagonal architecture. At its core, this architecture is based on the concept of separation of concerns. It provides a clear segregation between the business logic of application and the infrastructure components, such as web storage, third-party services, APIs, browser events, and you name anything that kind of not related to the domain logic, something external. So this separation is achieved through the use of ports and adapters. The business logic is encapsulated within the ports. So ports are usually interfaces that define the input and output of the core business logic. And adapters, on the other hand, are responsible for connecting the ports to the infrastructure components. It is the same function as of adapters in the software design. So basically, they map internal interface to the external one. The application might have one or more inbound adapters that handle requests from the outside world by invoking the business logic. And similarly, the application might have one or more outbound adapters that are invoked by the business logic and call external application, external services. So this separation provides one important benefit. So our architecture becomes agnostic to the outside world. So we can easily swap one infrastructural component with another without introducing any changes to our core, to our domain logic, business logic. For example, we can migrate from, let's say, Redux to React query, and our core logic will not know about it since it will be decoupled from the external interactions. Thanks to this decoupling, this sort of migration can be applied gradually using strangler pattern, migration pattern. So not as one big overnight change that can be deployed on the Friday night and break a lot of things. And it also simplifies testing a lot. So we can test things in isolation by mocking the infrastructural components we need, or we can also introduce stubs if we want to be independent from the backend. But yes, we also need to keep in mind that we have this layer and we have these functions. We have these functions that we need to consider when we build things, and I personally can live with that. So it's not a drawback; it's more like something that we need to consider. Here in this picture, I try to represent example of the hexagonal architecture in the front-end world. So we have UI and routing event handlers as inbound adapters, since browser is an outside world for our application. And we also have our outbound adapters. So in this case, it might be Redux for managing the global state, our, let's say, data access layer, some SDKs or API clients to integrate with the backend. We will go over some implementation examples later. For now, I just want to introduce a concept so it can develop into something more clear for you in the future. So let's review example of a food delivery system called Food2Go, where consumers can pick menu items from the restaurant and place the order. Restaurant admins can use web UI to edit the menu items and process the orders. By the way, I took this picture from the well-known book by Chris Richardson titled Microservices Patterns. And here you can see a high-level holistic view of the architecture with inbound adapters, for example, REST APIs, and outbound adapters as connectors to different third-party services, including Amazon, Twilio, Stripe, etc. So in the center, we have our core business logic represented by different domains, such as restaurant management, order management, delivery, and many other things. So basically, this is an example of the monolith architecture. Let's say our backend team migrated the system to the microservices. Here we can see that each domain now lives with its own physical service with isolated data and clean physical boundaries between the services. So, but our restaurant web UI in this picture is still a monolith, and it slowly becomes a bottleneck in the organization's communication structure. So let's try to decompose it further to simplify things in our organization. And here we meet the domain-driven design, or simply DDD. So it's not a specific technology or set of tools, but rather an idea of solving problems of the organization through the code. Basically, it is a set of patterns or guidelines that can be used to break down a complex domain model into smaller parts in a way that aligns closely with the real-world problem our system needs to address. DDD and Hexagon play nicely together. So the decoupling of the business logic from all the technological concerns makes the hexagonal architecture a perfect fit for business logic implemented with a domain model in mind. A few definitions that can be helpful, that can be useful. First of all, subdomains. So it's a separate problem spaces for our bigger domain. In this case, it's a restaurant management. Examples of subdomains can be order processing, kitchen, menu management, delivery, etc. Bounded context is another definition, and it means a logical boundary that hides the implementation details exposing an API contract to communicate with the domain model. In the end of the day, once we have all our subdomains and context identified, we can build the domain map, or let's say like context map. In this example, we have 3 different bounded contexts. Each context might contain 1 or more subdomains inside itself. 2 subdomains with 2 different contexts might communicate with each other only via like well-defined public contract. Within this contract, we need to ensure that there is no implementation details leaked, as the contract is slim and minimal and could be evolved in the future, probably versioned. Here you can see the order management subdomain crosses the boundary of its context in order to communicate with delivery live location tracking. It can be done like via like custom UI events or like I don't know, like via Redux, for example. The question left is how to divide micro frontends within this map. So there is no strict rule here. You just need to keep in mind that bounded context is the widest physical boundary we can have. And usually it is the safest option when it comes to migrating from the monolith to the micro architecture. In this case, we can start with one team, let's call it Team A, owning a single delivery micro app that implements capability of 2 subdomains, delivery management and delivery live location tracking. And later, split this micro app further into 2 apps, where each is mapped to a single subdomain and owned by 2 teams, in this case, Team A and Team B. However, I do not recommend to go in the opposite direction when you start with 2 micro apps and 2 teams and then merge them into one. Refactoring of the physical boundaries can become a real pain in the butt. So really recommend to play safe here and start with a bigger boundary first, and then divide it further based on like let's say increased domain knowledge on your side, or like maybe the business metrics that you have collected during that time. It's also okay to like have one team to own 2 bounded contexts, but also not other way around. So when the 2 teams share the same context and they kind of contribute to the same micro app and kind of have to share the destiny of the same product. Let's see how final front-end architecture might look like. So we have our 3 micro frontends built using hexagonal architecture pattern, exposing inbound adapters, for example, event handlers, and outbound adapters such as event dispatchers, API clients, in order to integrate with each other and also with corresponding backend services. You can see them. You can see them on the right of this diagram. And as you can see, each micro frontend on the left is mapped to the dedicated backend service on the right. Such architecture opens opportunity to produce perfect vertical slices within our organization, where each slice represents a multifunctional team of front-end backend engineers, QAs, PMs, domain experts who talk the same domain language and own the destiny of the business and software. Let's review some problems when it comes to the decomposition of the front-end application. First of all, first problem is like blindly following Conway's law. Conway's law states that organizations which design systems are constrained to produce designs which are copies of the communicational structure of these organizations. The key here is not to let your current organizational structure dictate your architectural decisions. Instead, it's about shaping your team and organization structure in ways that promotes your desired architecture. It's a shift from a reactive approach to a proactive one. And you need to remember that organizational structure should be a tool in the service of your architectural goals and not other way around. The next problem, I slightly mentioned it before, lacking or ignoring metrics. So you need to take data-driven approach to understand your user behavior and basically divide the front-end application based on this data. So if you don't have like metric collections mechanism, you probably need to invest into this first before you start the actual migration process. The next one, violating common closure principle. So as in the software design, common closure principle means if two classes change in the lockstep because of the same underlying reason, they probably need to belong to the same package. And similarly, in the micro frontend architecture, if we observe that adding features to like one application always causes changes to another one, basically, if it touches two contexts and involves more teams, it's most likely a sign of violation. Software changes affecting multiple bounded contexts are expensive and require lots of coordination, especially if the affected contexts are implemented by different teams. Probably we need to redraw our boundaries. And as I mentioned before, it's a painful process to do, especially on the system that is live, that is in production and has like real user traffic. And number 4, common shared dependencies. At some point, it may become necessary to share business logic between two micro apps. As this shared software evolves, it can become unclear who owns it, or ownership might be distributed among multiple teams. Sometimes teams have a good partnership with each other, and software evolution goes smoothly. But more often, issues arise due to, let's say, some geographical distance or organizational politics. Such teams may experience more and more integration issues over time. At some point, it may become more cost-effective to duplicate the functionality instead of continuously chasing one another's tails. So, if not addressed at time, this can lead to the creation of so-called God classes that try to manage everything but understood by no one. Another solution to this problem might be to have some platform team in our organizational structure who can like own these cross-cutting concerns and develop it further based on the customers' needs. In this case, like customers would be like teams that rely on this shared business logic. And let's stop here and review some simple React application for the restaurant order management. So React is a library that facilitates communication with the browser. However, we often overlook the details and end up tightly coupling our domain functionality with the rendering logic. Essentially, a React component should only render elements based on data and like trigger events to like share the data. Let me switch to my VS Code. Hopefully I zoomed it enough and you can see it well. If not, please let me know. So let's examine order details component that renders the status of the order plus some controls to do some management operations. In this case, it would be accepting the order or rejecting it. So let's start with reviewing of the markup. It's pretty simple. So here we see some fields that we're mapping from the like order entity, and we have a few buttons to accept the order and to reject them to reject the order. Here we can also see that we have some user fact that loads the order when the component is mounted, and we also have a few methods to accept the order and reject the order that is connected to the orders API adapter we have. So I left a few to-dos here to like implement the business rules of our domains. It's pretty simple for the sake of the example. So like we need to validate the user that the user has required roles to actually perform the operation, validate the order that like whether it's eligible to be processed or not. So it's pretty simple. But the problem here is like we are mixing the business logic with our like presentational logic. So it kind of might become cumbersome, especially if like we are talking about some real world project that might have more complicated business rules. Let's try to apply the principles of the hexagonal architecture and find a way to move as much of our domain functionality as we can outside of the React component. So I have one hook implemented. So let's try to remove the stuff we have here. Yeah, so basically, this hook encapsulates exactly the same thing that we had in our component. So let's go there and see. Basically, it's pretty much the same stuff. So now our new hook plays a role of a port, creating an interface between our domain logic and infrastructure layers, like APIs and like presentation layers, like React component. And let's say one day we decide to migrate from classic REST API. So like let's review it here, like our orders API adapter. So it's pretty simple. So basically, it's simple fetch API calls to our endpoint, FTGO API. So nothing extraordinary here happening. So just API client. But let's say one day we decided to move from classic REST API to the GraphQL endpoints. In this case, it wouldn't be a problem. React component will not be aware of the swap because both adapters implement the same interface. Oh, I got yeah, it's called a bit differently. Yeah, order GraphQL adapter, and if we go deeper, you can see that here we have our queries and mutations that is mapped exactly to the same interface for the order management adapter. Again, nothing fancy, pretty standard GraphQL implementation. But here's the problem, going back to our hook. So our domain logic is still leaking framework-specific concerns here, like React hook, so like use state, use effect. In some cases, it might be okay, but there might be situations when business needs to build versatile applications for different types of clients. Let's say like mobile versus web clients, or like web clients written on different frameworks designed for different consumers and different needs. The goal would be to have our domain logic to be shareable between these different types of the clients and framework agnostic at the same time. So we need to provide a better level of isolation here. For this, I have a domain class. So it's a plain JavaScript object. So it's order management domain. So again, it has its own interface and implements exactly the same methods, and it takes like our order management adapter as an input for its like initialization. And here we don't have any React specific concerns. So, and we also have our like business rules implemented. So it's purely focused on the business rules and integrating with the outside world using the adapters we have. So again, we are using the same adapters, and basically, if we want to migrate from one adapter to another, we can just pass it down to the constructor. So things like all adapters implement the same interface, it would work just out of the box for us. And in this case, we can consider these interfaces as our ports. So basically, it maps external interfaces of the APIs to internal interfaces of the domain model. Again, it's nothing extraordinary, just a simple interface with the methods that needs to be implemented in like every adapter. Yeah, so it's pretty simple. Yeah, but like the question here, like how can we make it accessible to the rendering component? So there is a solution for that. So if we are using if we are using React, we can pass these domain classes via props, and I have this simple helper method that kind of mimics the dependency injection mechanism. So as you might see, we have our domains initialized here, and we return them as a singletons if needed. So potentially what we can do in our order details, we can pass these adapters as an input, or we can like wrap them into some like React context, and they would be accessible from any like point down the tree. It's also possible. But if we use something like, for example, Vue.js, we also can leverage the built-in the dependency injection mechanism that it has. So it might look something like this. So we can define the injection tokens, and we can access the services by this token. So we simply can just initialize our domains, and we can pass some stuff of some adapters down there. So I guess pretty similarly to Angular. Angular also has. I haven't been working with Angular for a long time, so I'm a bit rusty in the syntax. So I won't even attempt to do that in this project. So let's now let's review how we can like design the domain events. So let's say order details page should also render the live location of the delivery guy. So restaurant admin can see where the delivery guy is on the map. For this, it needs to integrate with a widget implemented by different team, like let's say like team who manages like delivery bounded context. So we have it in our markup here. So we have some widget that is imported from somewhere outside. But in order for this widget to work, it needs to be aware of like what order ID admin needs to track. We can also implement this logic as a custom hook. So I have it here. So show delivery widget would be called in somewhere in the use effect. So it would depend on the order ID. If we have our order, we can call this show delivery widget method, and it will pass some event down to the widget. So it would understand that it needs to render this allocation for the delivery guy for this specific order. Let's go and review how it looks like. Again, nothing fancy. We have our adapters. In this case, it's implemented using the let's say like using the like window using the methods that was pre-registered by the delivery widget in the window scope. So here you can see that we tried to call it like using like some RPC like way. So we looking in the delivery widget existing in the window scope and like trying to pass event, trying to call the method that is responsible for the specific event ID. And if we will take a look at our like implementation of the port, we can also see like not only the methods that adapter should implement, but also event interfaces and event payloads that is connected to these interfaces. We can also go a bit more fancy and implement some versioning here for this sort of communication between the bounded context. And again, like let's say delivery widget team decides to switch from the like RPC-like way of communicating to something, let's say, based on the custom UI events of the browser. And again, it would be just a matter of creating of a new class that implements exactly the same interface for the events and for the like publishing methods. And we can review it here. So what has changed is basically the way we pass in the event. In this case, we create a new custom event with the same payload and with the same event ID, and dispatch it via like browser native dispatch event API. So it's simple like that. And again, we can also like wrap it up into some like domain class and like use like plain JavaScript instead. But again, like this hook is kind of didn't have any like React specific stuff. But again, like it looked like a hook, and it's kind of implicitly tells that it's something like React specific. So instead, we can again implement our class, and we can use our dependency injection mechanism to map this class and to the right adapter. And basically, you already saw how it can be done. This way, we can have like multiple web clients reusing the same domain logic, and it will work seamlessly since it's like vanilla JavaScript and it doesn't depend on any framework. So basically, might like you can just use the same domain model, the same domain logic between different types of clients, and yeah, it would be easy like that. Yeah, and that's basically it for my demo. Thank you a lot for staying with me, and yeah, let me know if you have any questions.
Thank you so much for your talk, Ildar. So we have a couple of questions from the audience. Let's start with the first one. And this is: domain and entities directories in the file structure are common in a DDD backend. Do you see value having these directories in the front end as well?
Okay, domain and entities. Okay, yeah. Basically, it's the same idea. Yeah, I didn't go like deeper into like entities, like aggregates, etc. But like entities is like, again, it's a crucial part of the DDD. So basically, it helps you to describe the models that can be identified and can be used across the business logic. So like I have like this implementation of entity in my project, like for the order, just very simplified form of it. But essentially, it's reused across different parts of my project, in the adapters, in the domain models, and basically everywhere. So like it's essential part. Regarding aggregates, I wouldn't say that it's fully applicable the same way as it's applicable in the backend, since like backend usually uses aggregates for preserving consistency of the transactional boundaries. But in the front end, like it's hard to talk about like transactions, since it's like not like really transactional environment. Yeah, I hope I answered the question.
Okay, the next one is, would you say that it is a good idea to start by having one micro frontend for each microservice? And if so, is it a good idea to share the domain object between the UI and the server?
That's a good one. I would answer that it depends. It depends on the different business needs. It's hard to tell that, hey, that's a requirement. You need to have exactly the same mapping between backend and frontend. I just showed some in my demo. I just showed some ideal picture of how it might look like, but it doesn't mean that it will work for any cases, for every case. The question about is it good to share the domain object between the UI and the server? I mean, I guess it also depends because because yes, as usually you probably will hate my answer, but it's all depends. So it depends on the implementation. Usually backend implementation is more complex, and you probably don't need exactly the same domain entities being reused in the front end, but you kind of can share the interfaces, right? You don't need to reuse all the attributes of it. So yeah, I guess in some sort of way you can share the domain objects, but not fully. It's again different environments, different execution.
Different tasks too, right? So it's different. Same but different. Yeah. As for the micro frontend for microservice, I think it's pretty difficult, right? We have some use cases where the micro frontends also intertwine. So one micro frontend needs to extend capabilities of another micro frontend. So not all the time possible, I guess. Here, the next question. I would love to take a deep look into this sample repository. Is it public? Do you mind sharing it with us?
yeah, I will definitely share it. It's not public yet. I just built it during the weekends, so I didn't have time to to make it public. But yeah, you can follow my blog, and I probably will write some articles there, based on my presentations today, and I also share the sample project I have here. So yeah, just stay tuned.
Okay, very good segue. So where can the people find your blog and subscribe to it?
Yeah, so it's thesametag.com. Yeah, I had it during my presentation, but let me show it again. Oops.
Please show it again.
Yeah, let me play the presentation, and yeah. So yeah, thesametag.com. That's my blog. I write a lot about not only micro frontend but some different technical stuff that I'm interested in. So yeah.
Okay, so everybody that is interested in checking out this repository, make sure to follow thesametag.com. And then let's move to our last question before we enter the raffle. How do you map the backend entities with the front-end entities?
Here I want to clarify what exactly map means. Does it mean
so maybe the ready Muraj can explain this a little bit further in the chat, and we will jump to the next question and come back if we have explanation what map means.
Okay, should we always split backend into microservices during micro frontend implementation? No, it's not necessary. These are completely two separate sides of things. So if your organization allows more flexibility on the front end side, but not on the back end, it's not a problem. So it's just backend just will expose some APIs that micro frontends can use, and it can live like that. So it's all these micro architectures is more about scaling the teams. So if you don't have teams that is mature and big enough on the backend, but you have it on the front end, so it's not like a blocker for the migration. But you just need to be careful about drawing the boundaries and identifying the domains and contexts that you need. So yeah, just if you feel you need them, you need a micro frontend, yeah, just go with it. Kind of depend on the backend.
Okay, awesome. And we have also a clarification for the question beforehand. So do you use a custom mapper when you receive the response from backend, or do you just use the classic mapping without changing the properties of the object?
In this case, I didn't use it, but usually need to do some transformation of the model from the backend to some, let's say, DTO that can be reused within the main model. So yeah, I would say I probably would use some like mapping function, transform function in the real project, since you probably don't need all the attributes that is returned from the backend, and yeah, it's kind of safer to have your own interface for the domain model.
Okay, we received one more question that I think is very interesting and fits very well into your talk. So, and we have a little bit more time. So, what is your recommendation regarding the debate on whether domain knowledge should reside in the backend or the front end?
That's
So,
a good
where
one.
is the source of truth? It depends.
Yeah, I mean, like the source of truth should be like in the hands of the domain expert who is like, I know, like, not, I guess not all the projects have like the domain expert who is kind of more into the business of things, like understands the business and how like the business processes works. So I guess you don't need to have a debate between like front end and back end in this case. Like if you have like a single source of truth who knows the domain better than everyone else, and probably it's better to rely on their knowledge and do the decision based on this. But if you don't have like domain expert, I don't know, like it's there should be no like pulling the blanket. I guess it's just should be collaborative. You need to work in the collaborative environment and try to build these like boundaries together. At least try to do that. So there should be no debate, just collaboration, partnership.
I'm thinking about maybe even how the whole application is designed, right? If it was built from bottom up or from top down, depending
Yeah,
on what kind of data is the most essential part, right?
yeah, like some organizations like a more like UX driven, like requirements come from the top, like from the designers, etc. But
Exactly. Yeah.
sometimes it's like API driven. Yeah, it's kind of, yeah, it might depend on this. I think so, yeah, but
Mm-hmm.
not necessarily. So I guess.
So no single source of truth here in the domain-driven design. Ildar, thank you so much for your time. It was an amazing talk, and thank you so much for being part of the Micro Conference 2024. And we will jump to the raffles now.
Yeah, thank you so much for having me.